Hi, everybody. Welcome to AES SMPTE Night Join meeting. Unfortunately, excuse my French, I'll be talking a little bit in French and a little bit in English. So stop me if you have any question around the French part. So Anthony Kuzik was supposed to be here. Unfortunately, he's sick. He came up with a flu. So we'll have Anthony talk for 30 seconds before we start our meeting, just to present and say good evening. Go ahead, Anthony.
Hi, everyone. You can hear me there? Yeah? Audio's good?
Yeah, they can hear you.
Okay, I'm attending remotely. You know, this is a cloud event after all. I'd love to be there with you, but my hearing comes first as I'm recovering from an ear infection. My colleagues have prescribed more cowbell for the fever, but I can assure you it doesn't help. On behalf of the AES, I'd like to thank SMPTE for joining forces to bring us such an engaging, relevant event. Huge kudos to Laurence, Noor, Tony, Craig for all the behind-the-scenes work that keeps the SMPTE machine running smoothly. Let's get a round of applause for them, if I could. Please just give them a round of applause. At the Toronto AES, we unite audio engineers socially. Within our allied arts, we collect, collate, and disseminate scientific knowledge that furthers all fields of audio engineering. We aim to empower people of all ages through participation in healthy, safe, open community events of shared learning and presentation. We explore audio engineering through events, presentations, networking, and mentorship, much like this event. The AES doesn't venture into the uncharted territories of cloud-based production as frequently as our television engineering colleagues. So this event offers many of our members a valuable glimpse into a new and wonderfully exciting field of remote production. We all know that the hardest part of video is audio. But what many may not realize is the hardest part of cloud production is computer audio. All right, with that, I'm going to do a shameless plug. Please pull out your phones, get your phones out, visit the torontoaes.org/expo25 for details on our 2025 audio exposition. The AES Toronto Expo 25 is a one-day audio technology showcase taking place on Tuesday, June 24th at TMU University in Toronto. Expo 25 brings together audio manufacturers, distributors, retailers, designers, innovators, and evangelists who will be shaping the future of audio technology. With that, I wish I was there. I know the pizza. I could smell it from here. Somebody sent me pictures of the pizza. Shame on you. So please enjoy this event, and I look forward to a full recovery where I can actually sit down and watch this video. Merci bien, Laurent. Je suis excité pour ce que vient ici aujourd'hui.
Merci, Anthony. Thank you very much. So we have a busy night tonight, very informative and a lot of presenters. So let's jump on the presenter. So it's arranged by me, Anthony, Noor, and Angel. Our evening protocol is question and comment are encouraged and appreciated. Recording of the meeting will be available on the SMPTE and AES Toronto YouTube channels, and there will be a panel discussion at the end. So for that, this meeting panelists will include Henry Goodman from Carl Lick, Darby Marriott from Grass Valley, Erwin Cameron could not be here, but he sent us a little video, Simon Petno from CBC, Michael Crump from TVU, and Noor Hassan from AWS. So in this matter, cloud production, while offering significant benefit like agility and cost saving, present unique challenges related to data security, compliance, and operational efficiency. Everything that Anthony already mentioned. These challenges require careful planning and appropriate measurements to ensure a smooth and secure transition to the cloud. So the key challenges that our panelists going to discuss: data security in primary, compliance and governance, operational efficiency, skill gap or expertise, interoperability and vendor lock-in, cost optimization, network dependence, and data migration and integration. So our schedules are very tight, as you can see. So, and we have to apparently get out of here at 9:30. So let's start. Our first presenter is Henry Goodman. He's from the UK, so he's Director of Product Management at Carlec Audio. Having initially studied mechanical engineering and at Manchester Metropolitan University, Henry Goodman has over 30 years experience in the professional audio industry and joined Carlec in 1998. As Director of Product Management, his role involved developing new technology and drive growth through new product development and geographical expansion. So go ahead, Henry, you can share your screen and do the presentation. And unmute your mic.
Okay.
You're good.
Yeah. Hello, everybody. Hope you can hear me okay. Thank you very much for that introduction, Lawrence. In view of Anthony's comments, I'm going to start the session off today by introducing you to, yes, some audio products from Carlec. This is what we call our Impulse V product, which is a cloud-based audio mixing console. So what is it exactly, do we say? Well, it's a software-based virtualized broadcast audio mixing console. It's configured for an AWS cloud environment. And what this means is that customers can deploy the software on their own AWS accounts. And we'll show you a bit more about that in a little while. But similar to our hardware on-prem cores or our physical cores, the Impulse V is provided as, if you like, two software packages. And these are split into control areas and DSP areas. So the first is a software package, which is basically what our master control system, or we like to call it our MCS. And this is in fact the same MCS that we use on our dedicated hardware cores, and is very much the core IP of Carlec as an audio mixing company. What it does is it provides the control interface between either physical services or virtual control mechanisms and the DSP itself. It also serves a number of web-served applications. So I'll show you these in a little while, but we have an assist application, which is our virtualized console controller. Configure application, which we use for configuring network protocols and the physical surface as well. And of course, an updater package alongside that. The second package is all about the processing, the DSP processing, the mixing processing. And this is a DSP mixing processing running obviously on x86 processing, provides all the DSP for processing the audio and mixing it, but also for routing and the I/O implementations in and out of the core. So the next slide I'm going to show you is this one, which is just how those two software packages live within the VPC of your AWS account. Basically, each software package is installed within two EC2 instances. So the DSP instance actually uses a machine called a C6i 4 extra large. So this is an EC2 instance of a specific size. And the MCS package or software lives in a separate EC2 instance, which is a T3 extra large instance. And these two instances live together within the VPC and are networked together for control purposes. You'll also see that I have control of the MCS from a physical control surface or the virtualized virtual assistant, which is web served from the MCS. The other part of this picture in terms of audio, certainly, is how we get audio in and out of the DSP itself. For this, Impulse V uses the Dante Connect infrastructure. And what we've done is we've embedded a Dante virtual sound card within the DSP. That's the Dante DEP device. And that is, think of that as a Dante virtual sound card. Actually quite a wide Dante virtual sound card in terms of audio. It can process 256 channels both in and out of the DSP. In order to manage that Dante virtual sound card, you do need the Dante Connect infrastructure, and you install that within EC2 instances within the same VPC. Which means that you need an instance for your Dante DDM, which manages the licenses for DDM. And you also need other virtual sound cards to connect to third-party devices. Within the Dante Connect collection of software, there's also an application that Dante called the Gateway. The Gateway is an extended virtual sound card, which provides extra buffering. So we use this for ground to cloud connections using Dante Connect. So this is the very basic infrastructure and structure of the of Impulse V and the I/O connectivity within a VPC that you would set up in your AWS account. I'm going to segue a little bit from my PowerPoint now, and I'm actually going to show you the instances that I have running within my AWS account. So this is the Calrec AWS dashboard, and you can see here that we're running these instances in a data center actually in London. You can see that from this indication here. So these are 5 different instances I've got running in that data center. The important ones here are the Impulse V MCS and the Impulse V DSP instances. So that's the Impulse V software running in those 2 instances. And you can see here the instance types that they're using. I also have some other instances running alongside that. I have my DDM Dante instance running. I also have a Windows instance running, so I can get some audio in and out of my DSP from this instance, which is a Windows instance running a version of Reaper with an Ordinate sound card on that Windows instance, playing audio into my DSP. I can access these the web-served applications that I talked about simply by accessing the public IP address. So you'll find that here on the details of your dashboard, the public IP address. And if I just put that into a browser, I will get access to this application, which is our Assist application, which gives me full control over my instance in the London data center. So this is a virtualized control surface for a CowRec audio mixer. Provides everything from fader control, so I can change the fader levels. I can access processing, EQ, dynamics, routing, panning for any particular source within my console. I also have access to the configure application. So for setting up control surfaces, for setting up my network interfacing is all done through this web-served application we called configure. So that's a very quick view of the instances running in my AWS data center in London under the CowRec account. I also have an instance of Reaper running in Windows, as I said, and I can access that simply through a shared desktop application, and access my Reaper from that shared desktop. Okay. I'm now going to flip back to my PowerPoint and continue with that. So you'll notice from the previous diagrams that I can connect physical surfaces directly to my AWS instances. They include the CowRec Argo family of surfaces. So that's Argo Q, Argo S, and Argo M. And these connect basically with a direct connection, very similar to a connection that you would use between a surface and a physical core, a physical hardware core on the ground. It's just connected using a different IP address. In fact, the same IP address that we accessed the virtual control system, the web-served application. In terms of what an Impulse V console gives you, basically there's one license available for that at the moment. It provides you with 256 audio paths, and that's configured as 128 input channels and 128 output channels for mains, groups, auxes, and track outputs. At the moment, I mentioned that we have the AWS implementation running with the Dante Connect IO infrastructure. Just to give you a little bit of a view of our roadmap, we are looking at providing NDI interfacing in and out of the DSP. We're also looking at orchestrated deployment, so we provide more automated deployment of those instances using Terraform scripts. They're available for customers to use. And the next stage in our development will be to look at private cloud deployment on COTS hardware. So that's the end of my presentation. Be happy to take some questions if anybody's got some.
Just one, because you're remote. You're using Dante controller? Are you using also Dante manager?
Yes, we use Dante domain manager, which is running in an instance within the cloud. But we also use Dante controller locally to manage sources within a particular instance. So we will use Dante controller within the Reaper instance to manage the patching within that virtual sound card and that instance. So yes, a combination of both.
Is this a special Dante virtual sound card just made for cloud, or is it the regular one you can purchase?
No, it's you have to purchase it from Ordinate, and it's managed through the Ordinate DDM, the the Connect DDM that lives in the cloud, and that the DDM that lives in the cloud actually manages the virtual sound control licenses for the cloud.
Okay, thank you. Anybody else has a question? Hold on. Go ahead. We still have 2 minutes.
What is the processing delay due to cloud infrastructure, please?
Well, the processing delay within the cloud itself is pretty quick. I mean, there's not really a delay. There's not really a significant delay in the cloud. Obviously, you're talking about audio processing, so there will be a slight delay, but we're talking very, microseconds of time for delay of actual audio processing in the cloud. When we talk about doing productions in the cloud, there are two main areas of latency that we worry about. The first is the latency of getting audio from the ground to the cloud, and that very much depends on the connectivity that you have to the ground. Can be typically something like 20 milliseconds or even longer. But the issue, that audio delay isn't really that much of a problem. It's this problem that most remote productions solve anyway, when they backhaul audio from any remote location to their studio hub or to their main production center, and can be managed through delay and that sort of stuff. Probably the more significant latency that we worry about is control latency. So in other words, when you lift a fader on a physical surface on the ground, how long does it take for the audio to catch up in the cloud? And for that reason, we recommend that you use a data center as close to your ground control studio as possible. So to give you a feel for that, we have systems at Carrick where we are seeing a round-robin delay to the London data center from Carrick, which is approximately 200 miles away. And with just a standard internet connection, we're getting round-robin delays of something, or ping delays of something like 7-8 milliseconds. And for most operators, that's quite manageable. But if you want to try and get, for example, from a data center across the United States from one side of the coast to the other, from east to west, you're probably talking about latencies of 20 milliseconds, something like that, which starts to become a little bit unmanageable for operators.
One more. What's the buffering number you put on the Reaper? 2050? 250?
Actually, it's only because we're only using the Reaper. It's in the cloud in the same VPC as our Impulse. Our Impulse instances. I think it's pretty small, to be honest.
Okay,
less than 20 milliseconds. I can't remember the figure on the top of my head.
Okay. Anybody else? Because we're going to move to the next presenter. Thank you very much, Henry. It's a pleasure.
Thank you much.
And if anybody wants to contact Henry, you can contact Henry, or we can post his email address if you want more information. Thank you very much. Somebody changed the control here. Isn't there? Here. There you go. Our question, next presenter, Darby Marriott from Grass Valley. Darby Marriott is a solution architect at Grass Valley specializing in the Agile Media Processing Platform, AMPP, with over 25 years of experience in the media and entertainment industry. He has held key role in system integration, solution architecture, and product management. Darby expertise span post-production, file-based workflow, newsroom integration, master control room, and playout, and live production. At Grass Valley, he has played a pivotal role in delivering innovative cloud and hybrid-based solution for high-profile projects, consistently addressing complex challenges with cutting-edge technology and strategy insight. So please welcome Darby.
All right, thank you, Lawrence. So today I'm going to walk you through some of the perceived challenges that you and our customers have uniquely addressed or identified that we can address with our product portfolio. So when taking a look at kind of the trajectory that we've undertaken with our customers, we typically see kind of the migration starting with the storage and media asset management. It's a nice stepping stone into cloud adoption and kind of paves the way for the next wave, which is kind of the operations level orchestration that, again, still could leverage compute that is on-prem, but it's not until we get into the live production processing that we can now start to actually put the compute power into the cloud and, again, reap the rewards that way. And then lastly, looking at the full pipeline, basically everything encoding distribution that we can take advantage of the complete cloud ecosystem. So some of the objectives that the customers bring to us and centralized or unified infrastructure, reduce complexity, the unification of support, so not having to go and look at different support platforms and have a cross-training on a number of different applications. The orchestrated deployment, so how can we build this faster and deploy that out into our environments? Scalable and shared resources, certainly something that they can go, again, extensively build this up so they're not locked into a smaller capacity or maybe even over capacity for what ends up being the actual business solution. And then overall lower TCO, shifting more from, again, the OpEx or into OpEx from CapEx. And then also looking at what that security model is going to look like for them. In traditional sense, we have all of our equipment on-prem. We know the control mechanisms, how we can securely manage that, what becomes of it when it comes to the cloud, and then overall reduce carbon footprint, making sure that we can be eco-friendly in our environment. So some of the challenges that we've addressed, and certainly there's additional here that we'll cover, but as we just talked about with Henry and the latency, we'll talk about those concerns and how we can overcome those challenges. The remote operations, certainly we've had a lot of experience with that now with Remy and some of the other challenges that brings with full cloud adoption. And then we look at what happens to the legacy equipment. So we have, again, portions of that workflow that still might need to leverage the legacy equipment. What do we do about that? And again, security, how do we, again, address that within a new cloud environment? And overall reliability, this is something where it's new, perhaps untrusted technology. How can we be assured that this is going to keep our signals on air in our high-profile events? And then overall cost, right? We want to make sure that we're fiscally responsible. Obviously, we've got objectives to be able to lower the overall TCO. How can this address that? So our solution that we've been developing is called AMP. It's part of what we call our GV Media Universe. And this is basically, it's not a single product. It's a collection of many different applications that not unlike running an iPhone device, you've got applications you can download from an app store. This basically allows us to flexibly address multiple solutions. And while yes, today's presentation is going to be focused on the live production element of that. That doesn't mean that it can't extend into some of the adjunct type of workflows like the production asset management, the distribution side of it, and overall network infrastructure. So again, it's a platform meaning to address all of these simultaneously, whether it be through GV native applications or, like I said, through an app store that affords other third parties to be able to be onboarded into that environment and play within this overall ecosystem. So for us, it basically allows us to meet all those challenge points, and we'll see how it does that. So the fundamental installation of AMP basically revolves around cloud. And whether or not you're using compute that is on-prem or in the cloud itself, that is something fundamental to it that allows us to extensively architect the system and affords the ability to work remotely and with all the scalability security in mind. So we basically divided up. So the control plane basically is a hosted environment that Grass is providing our customers, and the data plane is all the compute that is hosted by the customers themselves. So again, it's bring your own. We certainly can sell COTS hardware, but in this vein, this is something where the customer's compute is going to be hosted in their AWS environment, for instance, and they would basically be responsible for maintaining that. And that's also part of the integrity model. So all the content is actually going to be living within that, both the live streams and the actual video asset material itself. So that is something that is going to be self-managed on that side of the data plane. When it comes to the GB side, this is something, again, we host. This is, again, a high availability environment. It gives us the scalability to onboard new users within the system, new user interfaces. And this is where, again, we have the efficiencies of the cloud to basically build not only a scalable, but a highly reliable environment. So this is an example of how we kind of build out the architecture. So it kind of starts, again, with that GV-owned environment that we basically have onboarding the customers and the tenancy, these users, and the environment in which we'll then host all those different elements. So when it comes to the actual compute, again, on the lower bottom portion of that in the data plane, this is where, again, we can bring up the data centers, and whether or not that's, again, your own hosted environment, that's where we'll then start to situate some of the different elements of the processing. Meanwhile, the users could be sitting out here on the edge. That could be part of the public internet. They can be then accessing all the control layers, being able to manipulate the control infrastructure, and then also be able to do updates as far as a maintenance mode for the engineers of the system. So this gives us an example of some of the elements of AMP. And really, it's fundamental to understand that the video pipeline that we're building is built, again, on these kind of microservices architectures. So you have multiple different applications that are all sharing this frame cache at the bottom. So this allows us to interchange in an uncompressed environment with low latency between the multiple different applications. And again, it could be a GV native app, or it could be something third-party that plugs directly inside that frame cache as well. And that will see some of the adoption that's happening out in the industry in that vein as well. And this is, again, fundamental to the system, obviously for any of the live production workflows to maintain the signal integrity, as well as the co-timing of, course, video, audio, and ancillary data. So speaking of the timing element, this is where some of the really powerful stuff comes into play. So we talk about one of the challenge points in latency. How can we minimize the processing delay that propagates through this ecosystem? And that's where we basically built some of these asynchronous workflows that we can instead of traditional time sense where we have to go and process on specific timing barriers, we can now start to compress that. So we can start to lower the latency throughout the pipeline and be able to pick off what we call our flows and be able to deliver something. If it's ready in time in the processing envelope, we can pluck it off and basically deliver it faster than we would in a traditional video sense. And this, again, gives us the ability to then further expand it, do more within that same timing plane than we could have in the past. So when it comes to some of the remote challenges, that becomes more the operator sense. How do I go and access something that is running in the cloud? And for that, we have unified all on web UIs. So these are some of the example web user interfaces that we have. So in the middle, this is our flagship Maverick X switcher, production switcher. This can, again, because it's all software, it can fully extend that to match whatever the customer use case is. We've got different applications for sports and replay. So basically, like our live producer, basically allows us to go and see all the different elements. In each one of these, you can see the pictures in those populated inside those UIs. That has to be then provided in a non-latent environment to the user operators so that they can go and manipulate the content, make decisions based upon that content they're seeing. And for that, we use flow monitors, which for us means it's basically a low latency, high quality WebRTC derivative. And that can be presented as a multi-view monitor or again on full screen monitors for that monitoring purposes of it. And that's, again, giving you examples, and of course, media management, camera controls, everything in a web UI to basically give that flexibility on the edge. When it comes to hardware, tactile panels, so we want to have the operators give, of course, the affordability and extensibility of software, but knowing that they still want to have that tactile touch and feel. This gives us an opportunity to, again, extend what we could do in software onto what we think traditional hardware panels, but now these are, of course, smart panels. They can be reprogrammed to basically mirror what's going on in the environment of the system. So again, in this case, again, a Maverick for our video production switcher. At the bottom, we have a audio board. And this, again, is something where we can partner with other manufacturers to give them the ability to onboard through a rich APIs so that they can take advantage of all those different applications as well. So speaking of the applications, this is where, again, we afford the ability to go and basically, like on a smart device, shop within an application store, over 200 different applications, and that's not only the GB apps, but also across all the different alliance partners that are also providing those. So whether it's an input and output, a graphics device, a mixer, all those can then coexist within the same environment, so we can start to build on kind of like Lego bricks to build a workflow that previously would have taken a lot of disparate applications to perform. And this is obviously always expanding. So when it comes to building this inside of a cloud environment, what happens? How do we go and design a system that has so many different moving piece parts? And it really comes to what are the biggest lifts that we need to do. In a live environment, we have to bring signals in. So those signals can be coming in a compressed form. We need to basically have enough horsepower to decode those, and then the way out, deliver an encoded stream as well. So typically we look at those, again, how many streams do we need to account for from a live input standpoint, and make sure that we have enough horsepower that we can go and decode those. The other considerations are is that something we can do in the GPU very efficiently, or is it something that still requires a CPU? So we have to balance that model out and make sure that we have enough compute in that. And certainly into the modern sense, these are some of the AWS instance sizes. We're using G6 instances, which can go very large as far as the number of GPUs as well as CPUs to be able to scale to a very large system. And again, there's also considerations. Do I need to put this all into one large compute instance to accommodate everything within the same compute instance, or can I share that across multiple instances if I need to spread the load, or also to spread some of the cost around that way, or for redundancy's sake? So again, all considerations we take into account, and again, there is not one answer. It depends on the actual production, but the important thing to note is, of course, we're able to go and flex and change those instance sizes from one production or another. So speaking of which, how do we go in to do that? Certainly you can do that within your own account, but we also afford tools that would give you that easy access. So as an operator or manager of the production system, you can go in and spin up, spin down those instances to be able to go and leverage the power of cloud compute there. But it also lets you go and change the instance sizes. So again, if you do have a production that needs to be right-sized, so we don't over-provision or under-provision, that allows you to do it directly within the user interface. Taking it to the next level, how do we then more programmatically or tempo-based start to script some of this operation out? And this part falls into the orchestration layer. And this is where, again, we have different tool sets within the product or extensible tool sets when you look at the third parties, say with a data miner tool set or the layer cake tool set. Tools that have gone deep into the API integration of say, all right, we need to go and orchestrate all these different elements, whether it can be, again, spinning up the number of inputs, spinning up the different mixers that I need within that live production chain, and when do I need them, so it can start to pre-provision those elements and make sure you have the compute available for you for that production. But again, once you've got these templated, we can then reliably redeploy those and then also iterate on them. So the next time we do the production, we can then increase or decrease based upon the requirements that we have within that. So it becomes, again, more repeatable environment and comfortable and familiar, so we can have that confidence within the reliability stack. Some of the other adjunct things that our partners done, camera to cloud workflows. So how can we facilitate the power of the cloud to ingest different video streams and be able to then use them in a cloud environment, share it across all those geodiverse disciplines. And that's one of the things that our partner Mavis is being able to do with their applications, to go directly to the cloud and then have those available assets available directly in AMP for repurposing. So this gives us an example of kind of what it looks like. This is what we call our dashboard. This is showing kind of the workflow from start to finish. So starting out here, we have the live inputs on the left side of the screen, and these can be a variety of different formats. So whether it be SRT, NDI streams, TS streams coming in, or again in the audio environment, Dante streams, for example, those can all be then fed into our ecosystem. Once they're available, it's basically on a common fabric. So kind of think of an internal routing subsystem that affords us then the ability to route any signal to any then consumer on the system. Those can then be fed in, whether it be multi-viewer, so I can be monitoring all those images, but they're then fed into our different video mixers, processing pipeline. And again, because of the timing algorithms that we've developed here with our frame cache, we can basically recursively put some of those inputs back in, loop them back out. Anything can be flexibly routed at any point in time. So it becomes a very free environment in which we can start to experiment around with different things, or for different productions, or in case of something that we need to go and circumvent, we can go and build around it to move a flow around it to get to our output. And then this gets into, again, the actual elements, the graphics coming into our video mixers, and then we may have, again, a live replay environment that we could insert in conjunction with that as additional sources into it, all that we can then have visibility to. Because these are web user interfaces, the multiple users on the system can all be sharing that in environment and building different user interfaces to tailor to their operational positions. So this is, of course, our vision, but how have our customers taken advantage of it? So this is one of the events that was produced within AMP. There was a Global Leadership Summit. One of the challenges they had was multilingual distribution. So they were using AMP to basically allow them to have multiple signal paths to then develop different audio output streams for their different multilingual outputs. And then it also afforded them the ability to, again, because it was only a 2-day event, obviously, they didn't have to incur the cost of any of that hardware. They were able to go and obviously build this up ahead of time, but then reliably spin this up before the event, run it for just the 2 days. And again, they're only accounting for just that small subset of time in which they're actually incurring the cost for the software as we use tokens. But again, it reduced their overall expenditures from a traditional system that way. And because, again, it was something that they could flexibly do in the future, that's something they could reuse within that architecture as well. Another one, this is MVP. This is something they took advantage of, Live Touch X. This is basically for replay applications where we could go and leverage the cloud for bringing on the different matches for the sports league. And this also allowed them to, again, build up and support over 1,200 matches over the course of 10 months. And again, something where, again, they could set it up, have a smaller lead time in order to facilitate the actual architecture of the system, but then also have that scheduled for, again, when they need to spin up and grab the available instances for delivering those sports streams. So again, rapid deployment was key in their solution. And another one, this is basically a partnership we did with AWS, actually promoted on the blog. So this is something where, again, maybe not a traditional sense of complete live production, but they need to basically bring in streams into the cloud for recording, and then basically use those same streams to manipulate the content for redistribution. So in this case, able to bring in from the ground, basically the camera feeds, going through an AWS elemental encoder, pushing those streams into AMP. Those would then be accessible inside the AMP environment, encoded into a edit-friendly format using with Adobe Premiere. And those can all be accessed as growing files, so they can be quickly turning around the content that arrives in the system in a nonlinear environment and be able to then publish those out for, again, their purposes. So again, there's a lot of the different flexible use cases that we can take advantage of in AMP and really give a strong case for how we can start to leverage the full power of cloud across all the ecosystem. So with that, I quickly went through it, and so if there are any questions now or during the roundtable, happy to answer.
Thank you very much, Darby. Anyone has a question? I'll keep your question at the end because he's in person. Okay. So I guess we'll be at the end.
Thank you.
Thank you very much. Now I got two microphones, stereo. So next presenter is not here, but I guess Anthony would have liked to present him, but it's from Cameron.
Oh, I still
Cameron
can.
Alama. Pardon?
I still. How about I read the bio? Here, let me read the bio at least.
Well, you don't have to read that. It's the next one we need to read. This is This is perfect. But I'd like to present. You could present the video. Anthony?
Well, sure. Well, here I'll talk about lean and mean audio, Llama Mix. In this video, our colleagues, the founder of SMPTE Llama and Xavier Blanchette, technical sales engineer, walk through a setup of Llama Connect. Ewan Cameron was our colleague who did present this. Lean and Mean Audio, known as Llama, is a Dutch-based company that develops innovative live audio production software for broadcast, pro AV, streaming markets. The mission is to make audio products simpler, faster, and more efficient. Used by some of the biggest names in the industry, from the Olympics to online gaming. Llama has three main products. Llama Connect simplifies audio signal routing, acting as a virtual patch bay to connect multiple audio sources and targets. Llama Mix is a software-based audio mixer that replaces traditional hardware mixing console desks. Flexible, scalable, and cloud-ready solution, Llama Auto Mix is an end-to-end mixing solution that allows control of multiple mixes with ease, simultaneous, ensure consistent quality, and lower production costs. So, yeah, it's a very interesting technology. They offered everyone here a link to a free trial of this software. For those who are new to this type of industry, I encourage you to try this out as, kind of entrance in your ground to cloud, cloud to cloud, cloud to ground connectivity. They support MIDI data, enabling your MIDI controllers, or M1D1. Apparently that stands for lunch in Quebec. That word means lunch in French, but in English, MIDI is the musical instrument digital interface for our SMPTE colleagues who don't think of it as lunch. Please, enjoy this video presentation, and it's unfortunate they could be here, and just roll the clip. Is that how it works at SMPTE? I just say roll the clip. Thank you.
Hi, I'm Jeroen Dix. I'm the founder, Chief Product Officer, and Chief Technology Officer of Llama.
Hi, I'm Xavier Blanchet, and I am the technical sales engineer.
We are really sorry that we cannot be at Toronto, but we really love to have the opportunity to show our software in action. Xavier will demonstrate our software now.
Yes, I will show you a cloud workflow setup with our software Llama Mix and Llama Connect. Here you can see Llama Connect open. This is a patch bay and protocol converter working on a system of nodes. So as you can see here, you have the Reaper node. It's the output from the DAW Reaper, which is sending us 8 audio that I patch directly into the Llama NDI sender, which is going to send an NDI stream to the cloud. I also send the MIDI information from the V1M icon controller that I have here that we're going to use as a remote mixer. I send that via an NDI stream that I call, as you can see here, to the cloud. I have already an instance boot and with Llama Mix and Llama Connect already open, and it's already running and already connected. But first, you wanted to speak about the clock in Llama Connect, Jeroen, right?
Yes. So one of the problems of audio in the cloud is, of course, that all the cloud servers or all the servers in general don't have a sound card. So we overcame this problem by basically creating a virtual device in Connect. And the virtual device will generate a clock signal, and Connect itself will actually act as a sound card.
So yes, as you can see here, I have my receiver where I'm getting my feed, my NDA stream from the ground here in the cloud. It's connected to Mix, and I have also the MIDI information that's going into a loop that's going into Mix. But Jeroen, you wanted to speak about the MIDI into.
Yeah, so one of the things that we are doing is actually getting MIDI data from anywhere, from the sender, and we are converting the MIDI data into metadata. So using this methodology, you can actually send MIDI anywhere on an NDI network. And on top of that, we are also putting up to 256 audio channels in one NDI stream.
Great. And as you can see already in the base configuration, we have 2 NDI receiver if you need more. But now we're going to Llama Mix. So this is our other software. It is a broadcast software mixer where you can do and mix all your signal coming from ground or directly from cloud. You can mix that everything here. But Jeroen, you were speaking of clock earlier, so maybe you want to speak about the clock in Llama Mix?
Yeah, so we've already explained that Llama Connect is, of course, functioning as a virtual sound card, but how do other softwares actually connect to Connect? And so to do this, we created a virtual ASIO driver or ASIO driver, and the ASIO driver will actually receive the buffers from Connect and send it to the software connected to it, and the other way around. And so in this way, all the software thinks it's connected to a sound card, but in reality, it's actually connected to Connect.
Great. So as you can see, we are connected to Mix. So if I move a fader onto the mixer to open the fader, you can see that the MIDI information of me doing that on the ground remote controller is getting to Llama Mix, which is into the cloud. You can also see that I have a sound getting from the ground, from Reaper on the ground, into my Llama Mix. So this is at least going from ground to cloud. Now we need to send it back to the ground. So for that, I take the output from Llama Mix, which is my mix, which is 1 and 2, and send it back to a Llama NDI sender. I do that also for the MIDI information coming from Mix into this Llama NDI sender. We call it out cloud because it's going to come from the cloud and going back to the ground. So if we go back to the ground to connect on the ground, we can see here on this Llama NDI receiver that we select out cloud, so the NDI stream that we create into the cloud to go back to the ground. If I reduce the buffer size to 0 and I open the sound, you can hear that the sound is not good. But if we do it auto configuration, you can hear that the sound is getting better directly. But you wanted to speak about this configuration, right?
Yeah, so one of the problems with the original NDI VST plugins was that they often lost their sync. So you would have the NDI VST plugin running, and then after an hour or so, it would actually be out of sync with the images that you also had. And to solve this, we created our own buffering mechanism. And our buffering mechanism works more like a sound card. So it just has a fixed buffer, and then it will always stay at that buffer length. And when you press auto config, it will search for the first buffer in 20 seconds where it doesn't produce any underruns.
Okay, great. So with that, you can see that we did succeed to have a bidirectional audio link. So from ground to cloud, then cloud to ground, back with the audio, but also with the MIDI that's going from ground to cloud and cloud to ground, and everything is speaking together on those two places. So you can see with that we can have a configuration where everyone can work from everywhere in the world because everything is into the cloud.
Yeah, and so this is all based on NDI, but we are also working on a node for Ravenna, and we are planning to also support IMPX in that Ravenna node in the future. So, this is our demo. We hope you like it, and we hope to engage with you guys soon. Thanks.
Thank you.
There you go. Thank you to the folks at Llama Mix, Lean and Mean Audio for preparing that presentation. As everyone in the room knows, preparing content like that takes a lot of time. So we thank them for investing the time in presenting at our Toronto event. Over to you, Laurence.
Thank you very much, Anthony. Your voice is getting better. I guess you're less sick.
I literally have a magic bag on my head right now. So yeah, maybe that has something to do with it.
Is it a cloud bag or a real bag?
Well, it has grains, so it must be an NMOS bag.
Okay, on that note, let's go to our next presenter. Simon Bernod. Yeah, he's there. Simon Bernod brings decades of technical expertise to CBC Canada. With 25 years in television broadcasting, Simon has transitioned from operational position in the control room to engineering position where he managed complex projects. In recent years, his focus has been with OB truck build, national deployment, and centralized broadcast system, control room and acquisition workflow, including the work in transitioning La Maison in Montreal, La Maison de Radio-Canada, toward the 2110. His work on the Montreal project allowed him to transition with the team implementing the ABU DMF reference architecture at CBC Radio-Canada. Simon represents a wealth of experience in driving innovation and managing complex technical projects and broadcast media. Sans plus tarder, voici Simon.
Merci beaucoup. Hi everybody. Simon Bernod, Senior Technical Advisor with CBC Radio-Canada. I'll try my best not to forget the slides. It's always different when I'm presenting in front of people. I did this a bunch of times in front of the mirror. I aced it every time. Presenting on the enabling the transition to virtualized software for live production. So what is the problem that CBC Radio-Canada is trying to solve? In the 80s, we built a building that's right up the street from here, the Toronto Broadcast Center. And back in those days, we used to build specific studios for specific jobs. We had radio studios, TV studios, news, and those studios were tied to specific control rooms. In 2017, we did an exercise of decoupling the control rooms from the studios to allow a little bit more interchange and flexibility within the studios. But recently, with the work that we did at La Maison Radio-Canada in Montreal, we wanted to get into changing the technology within this space. But we realized when we started that we don't really have a crystal ball for what kind of productions the CBC will need to do in the future. So one thing we wanted to do right off the hop is we wanted to go from fixed purpose production facilities to flexible production facilities that can be dynamically reconfigured to handle different types of productions at different times of day. Being the national broadcaster, public national broadcaster, we have 27 television stations across the country. We have 88 radio stations. And we hope that by moving towards these software applications and virtualized environments, that it really underpins the ability to move to do more live production in regional centers across Canada without having to maintain infrastructure in these facilities. The studios and possibly control rooms in regions can tap into software functions in major production centers, and more regional production capabilities for much less cost. And the idea here is it would give them access to tools that they probably wouldn't necessarily have. So in the event of elections, rather than sending a bunch of equipment to bump up their coverage, we can just give them access to just more resources here in the data centers. So our target solution was flexible production systems based on virtualized software. So any good production engineering project always starts with a drawing, and our very first drawings were something similar to this, where we had a stacked vision where instead of having the studios at the top labeled as radio, news, or TV, we call them large, medium, and small on purpose because we don't want to tie them to any one particular purpose. Same for our control rooms. The control rooms are also labeled large, medium, and small, and not necessarily geared for any one particular job. And something that's consistent all the way through is a universal UI. So the idea with a universal UI is not exactly an exact replica from one mode to the next, but more a familiar sense so that when you're an operator in one mode to the next, that all your tools are more or less laid out the same way. So the stage that we're in right now is just the GUI. So we're challenging ourselves to try to run a show with a single laptop on a single GUI. All of this is going to be run from the data center with running with generic compute with infrastructure for on-prem and cloud. All of this is going to be software-based applications from multiple vendors to really pull on that best of breed that we've always been used to in the analog and SDI and all the transitions that we've done in our industry. And all of this is going to be dynamically orchestrated with a control layer sitting on top to help us reconfigure from one mode to the next. Last summer, we issued a tender for software-based production systems. And with that, we started with a relatively simple workflow. We have a couple cameras going into our workflows. This is going to some multi-views, is going to a vision mixers, going to some audio mixers. We have some outputs going to program and some return feeds going back into the studio. So using this, we defined a wide range of functionalities. We specified 30 different audio and video functions, video and audio inputs, video switching, audio mixing, multi-viewers, and other monitoring, graphic rendering, clip, record and playback, and general signal conversion and processing. This was important that on-prem or in cloud, the application didn't have a specific mode. So if it was running in one or the other, that it would run the same way, that there's not any difference between the two. We wanted the agility and the flexibility. An important point was multi-vendor, again, for that best of breed and allow us to pick and choose what it is that we want to use to build that workflow. We want low latency and optimal use of compute resources to try to get the most out of our data centers. So if we were to remap that same workflow, but if we were to look at it differently, so we would have small virtualized software components or functions or apps from multiple vendors, distributed across multiple hosts and to achieve resiliency and scale. Traditional IP streams to enter and exit the platform is always going to be a requirement. That's something that we recognize. Software components exchange media directly through shared memory. This exchange is asynchronous and faster than real time, dramatically reducing latency. and use of shared memory rather than streaming to reduce resource utilization. And then shared memory is bridged across multiple hosts using RDMA techniques used in high performance computing. So industry is much larger than ourselves that we can just borrow and draw from. So the results were we got so we got 12 vendors that qualified to the minimum requirements. 170 functions were proposed. A great positive was that key vendors are moving towards software. So a lot of the big players that we're all used to in the industry, but something else too that was kind of exciting was there's a lot of startups that were thinking a little bit differently that don't really have that baggage from years and years of doing broadcast a specific way. They're starting from scratch and gave us some really exciting products. Flexible acquisition models, so some had OpEx, some had CapEx, and some had a combination of both. No single vendor really provided full end-to-end functionality for all production workflows. Then the tender also surveyed support for existing or new multi-vendor platform initiatives. So this is Grass Valley AMP, Matrox Origin, Holoscan for media by NVIDIA, and Tiber and Lavo. No platform has attracted many partners yet. It was one thing that we noticed. Too many options causing hesitation. So nobody really wanted on the end user side or on the vendor side really wanted to jump on one thing or the other without really knowing, without really knowing if it was going to be the right choice or not. And for us as an end user, we were worried about vendor lock-in. So to get in too deep with vendor, we really can't get out, and that's something that we're trying to avoid. So tackling the issue of the multi-vendor interoperability in software-based production. Well, right after the tender was published, we worked really closely with the EBU to work on their dynamic media facility reference architecture. And in that document, they make reference to a stack of 6 horizontal and 3 verticals. The top 3 layers here are industry specific that we would control, and I say we as an industry. But then the bottom 3 are generic in that it's IT based, and a lot of these solutions and a lot of these things are probably already solved, and we don't need to spend too much time on developing anything new there. And it's no coincidence that the drawing from before maps perfectly to this stack from the reference architecture. But in this reference architecture, this document is fairly, there's a lot of stuff in there. There's a lot of things that we could solve, and we can all look at this diagram and we could probably think of a million things that we want to tackle at once. But if we do that, it's really going to slow things down. So as a group, it was decided that we wanted to focus on one particular thing to really get momentum going and really get some traction on this. And it was decided that the media exchange layer would be the best approach to really get things going. And for that is it gives us the best ability to get more vendors in in a way to agree to exchange the media between themselves. So deep dive into the media exchange, going back into the workflow diagram from before. So we have some cameras that are coming into the system. We've got some multi-views. We've got, this is a workflow diagram that we're all very much used to. And traditionally, we would have done this with devices, bespoke devices that probably did that function very well. But the only way to exchange media between these functions is to stream. And with IP, it allows us the ability to scale a lot more, but we still have to stream out onto the network and allow the next device to pick it up. There's frame buffers at each device, and every time that we stream out and back into a new device, we're adding a little bit of latency every time. It may not be much, but it cascades, and the more complex these workflows get, the more latency that we're going to notice. Now, the first generation of software implementations is great because today's powerful COTS computers or COTS allows us to combine multiple software functions in a single host. But in our early labs and our early testing, we had multiple vendors on the same host with their own media functions. But in order to exchange the media, we still had to stream out of the host onto the network and then back in, getting back into the same problem that we were having before with the media devices. Streaming is synchronous in real time. Streaming often includes buffering at each receiver. And if you're looking at NDI or SRT, it just adds additional latency due to the codec and a lot of those requirements. Streaming, transmit, and receive use a lot of CPU resources and require specialized NIC hardware and drivers, which can be cost prohibitive for a lot of folks. So an alternative approach is asynchronous media exchange in memory. So this is where we have multiple media functions within the same host. These media functions are able to exchange media directly in shared memory. So one function writes its data into memory. Another function can immediately read it from that same memory location. Doing this within the same host, this exchange uses zero CPU and GPU resources, freeing up the resources for more functions per host. So it's a more efficient use of that environment. Now, actually, there was a slide earlier that kind of explained this as well, but it's streaming has to be paced, so we have to wait till the media is out onto the network and allow one media function to pick it up. And there's a certain time interval to it that we cannot go around. But in media exchange, memory exchange, we can have asynchronous resulting in much lower latency. So we can achieve bursty signals, and if there's a media function that has the opportunity to spit out all of its content as fast as it can into memory and allow the next media function to read it, that's what this would allow. Now, it's all great when we have memory exchange within the same host, but now if we have more media functions that we want to exchange with multiple hosts, well, again, host-to-host exchange is achieved using standard RDMA methods developed by the IT industry. So we're not really inventing anything here. In fact, this is something that we're borrowing from the AI industry. So they're much larger than us, and they'll probably have hundreds, if not thousands, of nodes on their network. And so this technology is being driven by the high-performance compute applications such as AI. So direct memory exchange has been achieved by individual vendors and their own software solutions. So GVM, Riedel, Matrox, Origin, Intel Tiber Suite. But there has been no standardized way of achieving this across multiple vendors yet. So CBC Radio-Canada has spent the last 10 months working really hard with other end users and industry vendors to solve this important problem. So what are we doing to exploit this multi-vendor media exchange? Well, we proposed a common media exchange SDK. This is a shared library used by multiple vendors to exchange memory in software. And this would look like a media function or multiple media functions from multiple vendors. This SDK would specify a simple API for flow, create, remove, read, write functions. Common media buffer data model. Shared memory abstraction based on libfabric and IT industry libraries. And memory transfer providers for on-host, intra-host, and cloud expandable in future for hybrid on-prem to cloud. So this section here, the part in the middle, this is our section. This is the Media Exchange SDK. It's an open source software written by the media industry players. And again, we're not reinventing the wheel. The bottom layer, this is existing IT industry libraries developed for HPC workflow. So they've already spent the time and effort on trying to solve this problem. So why an SDK rather than a standard? Well, first point is reduce time to market. We don't have time to, we don't have to wait for historically long ratification process and allow for phased approach and follow approach that is being used by IT big industry initiatives. Reduce barriers to entry and development costs for app developers. So media application developers do not have to write software for media exchange layer. They don't have to adapt applications to multiple platforms, and application developers have saved time and money and focus their energy on functionality of their applications. And dramatically improve interoperability by having everybody everyone is using the same implementation, avoid issues related to interpretation of specification and higher velocity of evolution, and everybody's up to date. So really everybody has a stake in the game and it can contribute to the code, which really helps getting this adopted. So right before NAB, the open source SDK project was announced that it will be governed under the Linux Foundation umbrella. So this is not just anything theoretical. It's something that is moving. The train is moving forward with us. And the following vendors are already part of the open source initiative. And to show that, I kind of wish I had a picture or video of this, but at NAB, they were showing the alpha version of the SDK running, where they were interchanging media between two hosts. I think it was at the Dell booth and some at the Grass Valley booth as well. So, the alpha version is out, and it's being experimented with, and there's people tinkering with it at the moment. And yeah, that's it. Thank you very much.
Thank you very much, Simon. Simon. It's going well. I hope you're learning a lot tonight. So it's going to be an interesting evening, continuing on our presenter. Keep your question. He's coming back at the end. So we have two more presenter. The next presenter is Michael Cron from TVU. Michael Cron is Vice President of Strategy for TVU Network, where he leads the company's strategy and marketing initiative to deepen TVU's customer focus, innovation, and industry collaboration. Mike's brings a wealth of experience from his leadership roles, including founding chairman and board of Alliance for IP Media Solution, AIMS, head of product for live media service at AWS, and numerous leadership roles at Grass Valley, including Vice President of Core Technology, Senior Vice President of Strategy Marketing, and General Manager of the Server News Production Business Unit. Kronk has a MSEE and a BSEE from MIT. Is the author of multiple patents and holds a Technical Team Emmy Award for the contribution of NBC broadcast of the 1996 Olympics game. So Mike, take over. You can share your screen.
Thank you, Lawrence, and thank you, the SMPTE Toronto chapter. Can you hear me okay?
Yes.
Okay, great. Really happy to be able to present to you. Thank you so much Sorry I couldn't be with you in person, but you can have a beer with me when you go to the pub later. It's exciting to be at this talking about this particular topic because I've been dedicating quite a bit of my time over the last decade to figuring out how to do things in the cloud. First at Grass Valley with the AMP initiative, and then also at AWS, and now at TVU. And so what I'd like to talk about, I'm not going to talk about TVU's products. I really want to talk about what I see as the remaining challenges in cloud live production. We've accomplished a lot, but there's a lot more to do. So first of all, why virtual production, including on-premise and the cloud? As many of the speakers have said today, there's a tremendous capability for flexibility, the ability to burst to the cloud and scale up. Perhaps one of the biggest things is time to market or time to a solution. I need a control room. I can do that, put that together in hours, minutes, rather than months. Cost savings, especially for things that are sporadic in nature, like sports and live events, and the ability to reduce one's carbon footprint, not driving big diesel trucks and sending people in planes to places quite as much, for example. Since the beginning of when I was leading the AMP team, I think our first on air was February of 2020, right before COVID. And there's just been so many successes since then. And there's a lot of just trade press about it. These are just some of the articles there. So we have done a lot. And yet, if you ask yourself the question, how many of the live productions that broadcasters to do today are done in the cloud? This number here, it's not a scientific method, but I have talked to quite a few lead customers who say, there's some things that we do, like graphics workflows, remote commentator, master controller cloud, an occasional tier 3 production. But most of our control rooms are active and doing things on premise. And so I would venture to guess that, say, 1% of actual live production workloads have been lifted to the cloud. And so you can look at that as a glass half empty, and well, that's not very good. Or it's also a glass half full optimistic approach is, well, there's a lot of opportunity to improve if we just are honest about what are the challenges that we have today. And so that's what I've spent some time talking to various people in the industry, looking at my own company's places and just drawing from the experience from the other companies that I've worked for. And there's probably more, security being one that I don't have on this list, but is something to really consider when you move to the cloud. But these 5, managing your signals, the time that it takes to do that and the effort, configuring your applications, there's a lot of time there. And just with those 2, when you think about it, this quote at the bottom came from somebody. I didn't ask permission for actually to give a name, but this is a real quote. With the infrastructure as code, things like AWS CloudFormation or Terraform, you can literally program your EC2s to just press a button and they spin up in a couple minutes. But then to connect my signals, configure everything, that takes 4 to 8 hours. And so the outcome of that quote was, look, we can do this, but if I have to spend that much time for every production, it just doesn't scale. It's too much work on an engineering level. Contrast that to a physical control room where I go in and it takes months, even years to build and get everything right. But once I have that, everything's on the router, source, destination, take, I can fire a salvo and my show is ready. So the prep time for a given show in that room is actually less than it can be in the cloud if these issues aren't addressed. Another issue is just lack of a vendor ecosystem. You saw it in Simon's presentation, the big red thing at the bottom, fear of vendor lock-in. There's some amazing things that have been done, and there's different alliances and things where vendors are there. But if you ask yourself, are all the major vendors able to just interoperate seamlessly in the cloud? And that's not the case. And then latency, we can't cheat physics, and there's been some amazing things done, but I would say it's suboptimal. And then observability is another one. So just to go into these a little bit more, what do I mean by live signal management? Well, NDI and SRT are two very common methods. You see them in multiple presentations today. They're fantastic. But when you think about, okay, what are the steps that I need to connect NDI from the ground to cloud? I need an NDI bridge, and there's certain things that somebody has to go in and set passwords, choose the sources that you're going to put in there. And then I've got there in red, you have to do port forwarding. So you have to go from bridge your public IP to what your LAN is. Depending in sophisticated broadcast facilities, people know how to do that. But as you go out in the field and do live productions with some crews, there isn't that expertise. And so that's a blocker. And then you just have to go through a number of steps. Nice thing about NDI, though, is once you set up that bridge, all your sources that you've identified to go through the bridge, they're there. And that's nice. SRT has a number of steps as well, setting up ports, making sure that's all good. With SRT, you have to do that by connection, by connection, by connection. So if you have a 4-camera show, okay, 4 cameras. If you have a 25-camera show, that's 25. And oh, by the way, I'm just talking about inputs, not outputs and other connections that are all point to point. So that does eat up time. It's not press the button and it just works. The other thing is the configuration toil. It is possible, and a lot of vendors, it's a great first step, is you take your applications and you lift and shift, as we say. You spin up an EC2, you manage that EC2, then you put your application on there and you configure it. That isn't, when you look at other industries and how they really take advantage of the cloud, that's not the end state. The end state is more containers, being able to share content a lot more seamlessly, a lot less management of the infrastructure itself, and a lot more flexibility in deployment. And actually, the way that you do software in terms of continuous integration, continuous deployment can be better when you get to a more containerized approach. There are a lot of efforts right now to say, oh, what we're going to do is build these configuration scripts and make sure that all these lift and shift applications will be configured and can be faster. And those are great efforts, and they're useful and they'll be helpful. But I think the ultimate state is you don't have to do that because you're containerized. It's not, we need a square peg and a square hole, or a round peg and a round hole. We don't need a square peg and a round hole. So that's configuration toil. Vendor ecosystem, I think that's fairly obvious, and you saw it in Simon's presentation as well. I just did a survey of number of vendors with an on-premise solution, that's SDI or 2110, and then the column that says vendors with cloud solution, vendors with cloud solution. How many different vendors have production switchers or replay? And it's understandable, right? We're in a phase, and SDI for certain and 2110 have been along longer than cloud live production. But it is something that we need to catch up on, and it's encouraging to hear Simon talk about new vendors and opportunities there. Latency. So latency is one of these things that's a pretty deep subject. Audio latency, as you heard early from Henry, people are very, very, the perception needs to be, the latency needs to be really low so that humans can't perceive it. But this first of all is showing 3 latencies that matter in live production. So control rate latency, I press a button, do I get a response? How long does that take? video to video skew, 2 video signals. I'm looking at a live event and I see the event in the monitor. When can I perceive a difference? And then audio skewed, like 2 audios are out of phase, are out of sync. How narrow does my window have to be there? Versus what we're seeing in the distribution of content over through the cloud and over the internet with streaming. So I watched things like the Super Bowl on just a streaming service. That was very low latency. I think it was Fox this last year. I think they were talking about 8 or 9 milliseconds. Prime Video has a technology called Psi. They can get into that range for Thursday Night Football. But typical HLS streaming is more in the 30 seconds behind live. But it doesn't actually matter that much, except for spoiler alerts. And the reason is because you and I, when reviewing at home, we're not at the field. So the fact that it's latent, we're not perceiving that. As long as we're as fast as Twitter, as fast as the cable system, it's all great. Not so much in live production. So they've done kind of cycle analysis of human studies of how quick, what kind of latencies can humans start to perceive a lag or a latency. And so with control, that response to a button push needs to be within about 50 milliseconds. That's pretty good if you consider that the speed of light over fiber going 3,000 miles, so across the US or Canada, that can happen in about 24 milliseconds. So you can send a control message to the cloud. If you get a response back fast enough, it feels pretty good. And then video to video, it really depends on whether there's motion or not motion and whether your eye's focused on it or not, but 50 to 100 milliseconds. But audio is down in the few milliseconds. And you heard Henry speak to that. Like if the latency gets 8 milliseconds, it feels bad. And so these are some of the challenges that we have. Additionally, as we've done live productions, we've learned you take multiple vendors and you put their solutions in the cloud. And some of them have their own multi-viewers and others are using a different multi-viewer system. And what tends to happen is you're a director trying to call a show and people aren't seeing things at the same time. This is an example from a live production where the replay multi-viewer was coming back faster than the switcher or the mixer. So imagine if you're director and there's a 1 second difference. It's like, take camera 1, roll replay. It all of a sudden it's a little bit hard to manage when you get that. And of course, the ultimate challenge is video return back to talent. I'm an announcer. I'm at the game, goal, touchdown, and you see it live. And if you see your video coming back and it's with typical SRT buffer delays, maybe 5 seconds up, 2.5 seconds up, 2.5 seconds down. So that's 5 seconds without processing. That's a little jarring. So latency there's some challenges still with latency. And a really, really big one that can be overlooked, especially for companies that are just starting out in this, is observability. What do I mean by that? Well, the ability to monitor, log, visualize, and trace what commands are going where. And I kind of wrote out a quote here, or a statement. Observability isn't a luxury. It's really a lifeline. When you're on premise, something breaks, you can run down the hall, talk to somebody. You got a patch panel, you can put a scope on it. It's pretty easy in the physical world to figure that out. Software, there's all these interface, but it's just bits moving through the ether. And so without deep telemetry and real-time alerts, we're flying blind. And it's fine when it's all working, but if it doesn't work, you need to know fast, and you need to be able to course correct, because that show is what you're there to produce, and you produce it reliably. I do think there's quite a bit of light at the end of the tunnel. Up until now, you may have thought I was, kind of pessimistic on the cloud. I'm actually very, very bullish, because these problems are solvable. The challenge of live signal management, things like the EBU media exchange layer. I know my own company. I've been knocking on the door since December to join. I know a lot of the people that are doing it, that are some of the people committing code used to work for me, but it hasn't been fully opened yet. It's only the few initial partners. So we've got our name on the list to join and be a part of that. The VSF is doing some interesting work, the Video Services Forum, in something called Cloud Device Discovery. That's a project that AWS is leading that is going to make it all that kind of configuration with things like SRT. It's going to make it a lot simpler. You register ahead of time, all that information is registered, and then you can use and reuse that information, making that whole process easier. From a configuration perspective, TVU included. I know Lavo is this way, is using standard Docker containers instead of some other type of container. Docker is an industry recognized standard, and more people are moving in that direction rather than in lift and shift applications. So I see light at the end of that tunnel. Lack of a vendor ecosystem, as those things mature and increase, I think that is just going to improve. And as these other challenges are overcome, you'll start to get this momentum where it's kind of that whole crossing the chasm paradigm, if you heard of that, where you if you get enough energy, like a lot of people start to move. So latency, I know at my own company we've done a number of things to address the challenges that I spoke of. I think that there's obviously you can't cheat physics, but we know we can do a production across the US or Canada or transcontinental, and have video return through a production in under a second. And I know that I know at least one other case where that's happened as well, which is pretty good. And even for talent that's a little bit picky, seems to be fine. Observability, there are standard ways of doing things, writing error to standard out and standard error are logging to those. Open telemetry is a whole open standards-based approach to telemetry that people are adopting. And then with those, you can use standard tools like Prometheus and Grafana to build monitoring dashboards that allow you to have actually more visibility and more opportunity to respond and automate than you have on premise. So very bullish because of all these things. Thank you for your time and allowing me to share both the challenges and why I'm optimistic.
Thank you very much, Mike. Thank you very much. Anthony, I hope you had time to change your water in the bag. So I guess Anthony's gone.
Oh no, I'm still here. I just put it on 1111. Those are how I program a microwave. 2222. That's my other time.
Yes. Anybody has question for Mike since he's remote? I forgot about it. Oh, it's a tough crowd. Oh, he's got one in the back. Come on down. The microphone's over here.
Yeah, I won't hear a thing unless you're talking to the microphone.
So I just want to follow up on your 1%. Now I have to be. No, I'm not in front of the camera, guys. So we'll all be over here. Just following up on your 1%. Like, what do you see the timeline on that in terms of greater adoption?
That's really hard to predict. I think I think with things like EBU MXL coming out, I think we could see a really big wave in a couple years. That's coming out, and then people adopt it, and they the way I think this industry works is you wait till somebody starts to have success, and those people talk to their friends, and not everybody jumps in the deep end at the same time, and so it takes a little time. but I think the technology capabilities are getting really close.
Any more? Yes.
Yeah. We on here? Hey, Mike, how are you doing?
Good.
Anyway, just a quick question there. You talked about observability. We went through this when we worked together on the 2110 stuff. Do you think we're ever going to get beyond that issue as far as that goes?
Well, so that, first of all, that's Stan. Hi, Stan.
That is Stan, yes. How could you recognize my voice? Hard to believe.
It's hard to see you. So I'm sorry. The question was when we get past what the observability challenges.
Yeah, observability. You pointed that out as the last thing on your slide. There's an issue.
Yeah, I think we can. I mean, other industries do this all the time. They run banks and other real-time systems in the cloud all the time. The technology to provide observability is proven. It's just a matter of implementing, adopting it in our own, in our own software. So I think it's really going to happen, quite fast. That open telemetry's been around. It's not new and unproven, as an example. But we'll always have to.
We do.
Yeah.
We do have one more question, Mike.
Sure.
Oh, thank you. I just wanted to ask about the observability. Is there any initiatives going on between the different vendors, right? Because each vendor would have their own level of login observability. But what about when you're building these like multi-vendor environments? Is it really focused back onto people like the data miners to kind of pull that all together, or is there like any initiatives kind of going on around that?
Well, that's a great question. I think that there's this foundational level with things like open telemetry, logging to standard out and standard error. Those are pretty common things. Having an endpoint to write metrics to, like slash metrics for Prometheus, which is very common. So I think a lot of vendors will do that. If your question is there an open initiative to kind of have an open way to do what Data Miner does? I think there's a number of companies that their job is aggregating those metrics and making them useful and visible to users. I remember going one time, I thought, okay, my company at the time, we're going to build this comprehensive monitoring solution. I walked into a broadcaster in Southeast Asia, and with our solution, they promptly showed me a kind of a NOC that had monitoring solutions from 24 different vendors. So I don't know if we'll ever get to like the famous like one pane of glass with there's some open standard type of thing. But I think if we have endpoints and we use open standards, then it allows people to build exactly what they want for their company, or to contract with a data miner or a data dog or some other company. So I think that's the way it's probably going to go. That would be my take, at least.
Okay.
But I don't have a crystal ball,
though. Thank you. Roy has one question.
Hi, Mike. This is Roy Folkman. Thanks for your presentation. Hey, nice to see you. Question, the VSF initiative, you mentioned cloud device discovery and the EBU initiative. Are they aligned and complementary, or are they potentially or
they're
potentially competing?
No, they're completely complementary. And the VSF, by the way, that's an initiative that if you join the VSF, you can become a part of. Where there's a meeting every other week on Thursday mornings, at least Pacific time. It's Thursday morning. So the MXL is media exchange layer. That's about shared memory and remote shared memory, RDMA, between containers and processes. And so that That since once you get your media into the shared media environment, everybody can share it without having to encode, decode, without having to create a stream. That was a great presentation to summarize the advantage of that by Simon. What the cloud device discovery is, think of getting, not once the media is in there, how do you share it, but how do I get it to the cloud? So I'm sending SRT, I'm sending Zixi, I've got a high vision encoder, I've got a net insight encoder, I've got a Sony or Panasonic camera. How do I register with that device and securely connect to it so that I can get the IP address, the port number, what protocol, what codec? You can send all that information up automatically without somebody having to enter it. And then from the cloud, I can actually send a message to say play. And so I can make that connection remotely from the cloud without having to enter a bunch of data because I've authenticated my device. And so that, I think, essentially helps the MXLs. They're just very, very complementary as I see it.
Excellent. Thank you, Mike.
Thank you. If there's any more questions, then we'll have to move. Do we have more questions?
No, I just put in the chat, there's two other notable works in progress. There's the AMWA IS-12 NMOS control protocol, and there's also the AMWA IS-14 NMOS device configuration specification. It doesn't touch on some of the things that Mike was talking about in terms of discoverability, but these are extensions to the NMOS API ecosystem that really are an effort to tie things together. So those are just two other notable works in progress. But again, like none of these things ever finished. They're just works in progress forever, just like Ethernet. It's never done. It's just always being worked on and improved. So it's really good to see Mike echoing some of the sentiments that the other presenters have done. And then I look forward to our next presenter.
One more.
I'm new to this. The chart you showed at the start with how to get the IP address, you just talked about that again. Isn't there a way, or are people working on a way to much more rapidly get the address for the sending devices? So you skip that whole first sort of channel that you had shown earlier when you were showing the charts.
Yeah, one of the ways that's being done, I can say for sure, is that VSF initiative, client device discovery. So what it uses a protocol very common in IoT applications called MQTT. So when you're a consumer and you buy an Amazon Alexa or the Google device, that's that you plug it in, and it's once you get it on your Wi-Fi, it's super easy to set up an account, and now you're going. That's what the VSF CDD initiative will be. So it will do what you described. There may be other efforts. The VSF effort is the one I'm most familiar with.
Thank you, because I'm also concerned about reconnectivity if it drops.
Yes, if you lose your network connection, what happens? I believe that's covered, but I can't tell you how off the top of my head.
Okay, thank you.
Thank you very much. Thank you, Mike. I'm going to have applause for Mike. Thank you very much.
Thank you.
Okay, we're going to move on to our last presenter from Amazon Web Service, Noor Hassan. With 10 years of experience in the broadcast space, Noor is currently a principal solution architect at AWS, enabling broadcast vendor and system integrator to realize their industry superpower by deploying broadcast offering in the cloud. Prior to joining AWS, she worked with numerous global customers as solution engineer with Everse microsystem and manage solution architecture for compression workflow. So please welcome Noor.
Hello, hello. For the second time, I'm standing between you and the pub. I'm sorry. All right. So thank you for being here. Welcome again on behalf of AWS. What I thought I would, cover a little bit on today is a little bit of media trends that we are observing and talking about some of the challenges that we hear from customers and partners. And then we'll talk about some design considerations when you're looking at migrating to the cloud, and then share with you some resources that you can maybe take away. And so I will stick around after the session if you wanna have some further discussions or questions. Now, the thing is, in listening to all the previous presentations, if I had to collect one slide from each, that would have been mine in terms of messaging, which is really, truly fantastic. But to kick things off, let's talk a little bit about some of the trends that we're observing in the media and entertainment industry. So one of the things that we're seeing is the industry is undergoing a lot of transformation in terms of how audiences want to consume content. And so we're seeing a generational change whereby the younger generations want to consume, say, something like news through social media. And so I don't know if that's something you've noticed, but I've seen at least myself sometimes being lazy to maybe open some of the mainstream channels, quickly browsing through some of the social media to observe content and news, but also being aware it may not be the best source. The other thing that we are seeing here is the technology disruption. So you're hearing a lot about maybe conversions of IT, traditionally known as IT technology, that is coming into the space of broadcast. So, for example, or borrowing from other technologies like HPC. That is a really good example of that. But also we're seeing the growth of AI and generative AI and cloud. And so all of it converging together, which is enabling more experiences for consumers. And so that is really powering the behavioral change that we're seeing. And then the other part is the need for immersive and personalized experiences, right? And so if you are familiar with the HBO House of Dragon, they essentially enable this experience whereby you as a viewer can have your own AI generated poster and you can pick a side for the war that is going on. So having that kind of immersive and being part of the show, right, is something that we're seeing more of. And then finally, the intellectual property or IP expansion. So we're seeing this kind of more adoption or integration of gaming experiences into movies or TV series or shows. Are you familiar with Minecraft, the game that was back in? Yes. So there's a movie that got released this year that is based off of Minecraft, the game, right? So that is really interesting because it's a sign that viewers want to experience the video games that they play in the form of TV content, which is a very kind of interesting behavior if you think about it. And so what else are we hearing from customers who want to enable these trends, right? Who want to respond to these trends and be able to adapt to these very quickly. One of the areas is around operational and economic agility, right? And this was mentioned before. So Darby was, for example, talking about moving from CapEx heavy to more OpEx heavy, and so we're seeing that also in Simon's presentation, talking about like, hey, we don't have a crystal ball to kind of anticipate what the next production is going to be, and so essentially wanting flexibility to say, I want to spin up and spin down, maybe studios or production control rooms or master control rooms and spin them down, adapt them to something else without building all of these things in parallel. The next thing is innovation and experimentation, right? So in order to kind of respond to some of the trends that we are seeing, so integrating new, let's say, technologies like AI and generative AI or gaming or personalization, you want to experience quickly. You don't want to necessarily invest in so much time and resources to prep, let's say, the underlying infrastructure and services and applications, and then enable your creative teams to go ahead and start testing. Instead, you want to try, see what works, what doesn't. If it fails, we pivot, we move on, and that's fine, right? Or if you want to experiment in a new region, right? So you want to be able to do that also fairly quickly, see what works, what doesn't, right? And so PGA Tours, for example, did that, and they were able to shot every shot or every hole, and I think they had more than 80 cameras, and kind of produce these camera feeds where you as a viewer can tune into any of the camera feeds and watch that. And so for them, that was or started as an experiment and then turned out to be a really successful event. Obviously, with the technology conversion, so again, how do you adapt very quickly to that and essentially enable your consumers to have more personalized experiences? Cost is top of mind for customers and partners alike, right? And so how do you access the right set of tools to optimize your cost? Because especially in live production, these are not 24/7 workflows, right? Essentially, you want to pay for when your event is going on. Of course, there's some testing that has to go ahead of time, but also you want to optimize not only on the time when the resources are up and running, but also on the type of resources that you're using, right? And so, again, like in the previous presentations, folks alluded to that, whereby you want to spin up the right type of compute that would match your requirements at the time. You may need to scale up or down, right? Or horizontally, but you shouldn't have to spin something up 24/7 as a static type of resource. That can get very expensive very quickly. And then, last but not least, engaging audiences in their platforms of choice. So again, being able to consume content on any sort of device, plus having immersive experiences where you're part of that show. To give you a quick example, and you can read more on that. So NHL is an example whereby they wanted to reduce their carbon footprint. They wanted to have their show or support their games very quickly. So having the ability to leverage new technology versus what traditionally happened, they had to bring in approximately 20 humans to support an event, potentially in an OB van, right? But they wanted to try something else where they wanted to reduce cost. So speaking of cost and being more agile, right? So enabling remote production, whereby majority of the operators were remote. And so they were able to reduce their carbon footprint and also the cost of traveling, for example, and lodging the people that would normally be part of that show, right? And so they were able to set up their system in less than a month, right? So that is a huge kind of saving from a resource standpoint. And also what they did was they created what they call an alternative live broadcast called NHL Edge Unlocked. That's the name of the alternative broadcast. What that enabled them to do is to try to experiment with immersive experiences and personalization for their audiences. So kind of going back to that ability to experiment quickly, see what works, what doesn't, scale it or pivot. Another really cool example is the NBC Universal with the Paris 2024 Olympics. So compared to Japan Olympics, NBCU were able to stream, I think, 7,000 hours versus 2,000 hours. And so they were able to spin that up in the cloud, and they wanted to really enhance their entire streaming experience and reach more audiences. And so that's what they did. So they were doing this using 4K and Dolby Atmos. They're using some advanced technologies, right? And again, experimenting with more monetization and reaching more consumers. Okay, so diving a little bit into the broadcast specific use cases, right? When we talk about broadcast, this would be familiar to a lot of folks in the room, always starting from left to right. You're thinking about, okay, how do we then, what are some of the considerations there? So looking at the sources, where are our streams coming from? How do you normally contribute them to where they need to be produced? So if it's an OB van, or it could be the data center on premises, and then essentially you're ingesting them somewhere and somehow in order to feed your studios, right? So your PCRs and MCRs, and then if you have a news workflow, then you're going to have the newsroom computer system somewhere in there alongside your MAM. And then finally, once the processing is done, you have your content delivery. And so this is a very traditional workflow. So when we talk about the cloud, in fact, that does not change a lot. We still have to think about their sources coming from cameras on premises, like a venue or a studio, talking about live production, right? And then now you just have to look at, okay, how do I best optimize on the contribution? So Mike and others talked about that. Latency is a big thing that you have to take into account, right? But there are different options. So if you're contributing JPEG XS, then it does not make sense to go over the internet, perhaps. Maybe you want to invest in a more dedicated network, right? Or maybe if you are in stadium, you want to have experiences in the stadium. And I know some of the partners in the room, like Moby, do this very well today as well, is to have experience in the venue, right? So maybe using things like 5G or private 5G to enable that, and so on. And then once you're in the cloud, which is just a really far away, potentially data center from what you normally have under the desk, right? Essentially, you're receiving this content somehow. Don't worry about the icons for services. The point is, it's about choosing the tool that would work well for the application, right? So this gateway could be an elemental media service, right? It could be a gateway provided by TVU networks and many, many others. Once you have it in there, all the functions that you are normally familiar with are repeating here. It's no different. But really, when we talk about the cloud part, you're familiar with the intercom, with the vision mixing, with the routing, with the glue, right? That part is not changing. You're familiar with, hey, if I have an OTT stream, I need a packager, or maybe I need a stat muxer if I'm going over satellite. These functions are the same, right? What you're able now to do is to say, okay, so I know the functions. These are some of the vendors that I've normally worked with. So that's not different either, right? It's just changing where the infrastructure is running, some of the tooling that you have access to. But what's really, really key to keep somewhat familiar or similar is really the aspect of the operations, right? So this is an example whereby an operator who is used to a particular switcher or the audio engineer, right, or the replay operator, the graphics operator, they want to use the same interfaces that they use normally. And so operational familiarity is key, which is what folks talked about, right? So I think it was Henry who talked about latency becoming an issue if an operator presses a button, right, but then they can perceive latency, or there's a latency between when they press the button and they see the reaction in maybe the switcher, right? And so what you're looking at here is what Fox did with AWS for live production, right? So these are the operators who were operating from home. And so to them, it did not really matter where the, let's say, the software or the applications were running, as long as they did not experience different latency, right? So for them, it really did not matter. In fact, it made their lives easier. They didn't have to come on site, and they were able to produce a show. And so, okay, we think it sounds somewhat easy, perhaps, or, if all of these factors are not too different, why did not everybody already move to the cloud for live production? And that is a very fair question. Mike addressed that as well as the rest of the team here. But there are things that we, acknowledge. And so these are some of the factors that we perceive to be the case, right? And I'm not saying that's all of them. Mike talked about a bunch of others as well. But like remote connectivity and contribution solutions, essentially that goes back to the concept in that diagram where you want to choose the right tool for that kind of show, right? How do you get access to deterministic network that allows you to transport something like JPEG access, right? The other part is, silo dev and broadcast ops. We are seeing conversions of, IT and broadcast, at least in my opinion. But today, would you agree that they're somewhat siloed between broadcast operations and dev teams? Like, would you say yay, nay? Yes? Okay. And so what's going on there is that, we're moving really fast when it comes to technologies. Some of the things that people talked about, like, like API first design, or using, underlying common infrastructure like fabrics that process frames, or, having observability beyond just multi-viewers. But then what happens is that when the dev teams are working very separately from your broadcast ops, then that silo happens, right? So adopting DevOps best practices becomes a really, really important factor to acceleration. Multi-vendor deployment and integration, and Mike addressed that already, but I would also add interoperability, right? Because deployment is one step, integration is another, and then interoperability between vendors is key. If you look, or if you remember the slide where I showed a lot of vendor examples, right? It's not plug and play. And some of the things that we do hear from customers is like, hey, it may be easier sometimes to have an end-to-end system that is supported or like adopted from one vendor. It's just easier maybe operationally. However, what we're also hearing from other customers is that like, hey, we want best of breed, or hey, we want to be able to switch between the functions and the components from a vendor standpoint. Maybe today we want to try or start with switcher A, but then, next year, on a couple of years, maybe you want to try switcher B, or maybe like a new startup comes to market with a really cool AI solution, or like an awesome orchestration layer that we want to test. And so for them, having these modular, what they refer to solutions as modular solutions that are API first, because they want to be able to, well, plug and play in a way, right, as much as humanly possible. And so interoperability between partners and vendors becomes key, because that allows them to move fast and support their customers. Not enough observability. I think, Mike spoke about that beautifully, so I'm not really gonna say more than like, hey, I second everything that Mike said. And then finally, skill transformation. And so when we talk about skill transformation, it's not about replacing the current talent or the crew with a crew that maybe is more, IT able, or bringing in a lot of data scientists into the team. And also, when we talk about skill transformation, it certainly is not just about technology or the technical side. It is very important, but it's also about the business lens. So if you think about it, sellers, right, or the sales teams today, right, are in traditional ways, even from my previous, company as an example, are, let's say, adapt to ways where they sell hardware and software, right? There's ways of compensation that have been built over the years, et cetera, et cetera. And so one of the transformations is like, hey, how do we enable incentives in a world where it's all software, right? So that's another area that is coming in there. On the point of multi-vendor deployment and integration, I think a key component there is SIs, and so folks like, Diversified and Monks and Quest and others, we're starting to see them like really push further when it comes to cloud, because we definitely need their help to kind of bring it all together. And so these are some of the design considerations, that I thought I would share with you. It's not, inclusive of potentially everything that we could do. But essentially, if we start to foster a culture of innovation through what we call a cloud center of excellence. So in your organization, starting to build this logical entity of people, of resources who could be from different teams across your organization, but they become your cloud center of excellence, right? They are the people who are go-to when it comes to understanding the business, understanding the cost model, the economics, the technology, and then using them to also bring new people on board or enabling other people in the organization, right? We've seen this work outside of the media industry. COE is a concept that we've adopted with customers in different industries, and it works. The other thing is leveraging design best practices. So there's a concept of the AWS well-architected framework. It's a bunch of pillars, right? In fact, Darby talked about a lot of them, like cost optimization, security. Security is huge, right? Being operationally efficient, choosing the right resources for the job, all of these things, right, coming together. I always encourage looking at the well-architected framework. It applies not just for the cloud, but for design and architecture in general, in the general sense, right? And it's a set of best practices that AWS learned over many, many years and kind of providing that as recommendations. So it's a really good read. I truly encourage looking into it. It's really interesting. And then upskilling the teams and the businesses through resources. So there's something called Scale Builder, for example. A lot of resources, at least from an AWS lens, are free to use. But again, when you think about upskilling, it does not mean necessarily replacing talent. It's readapting talent. An example I always like to give is I used to work with a partner in Canada outside of the media world, and they had a group of probably 20 people or so who were IT experts in networking specifically. And so at some point, this partner was wanting to migrate to the cloud and provide cloud services. They were a system integrator. And at some point they thought like, hey, like, should we kind of replace these talents with other types of talents? And the answer was absolutely not. Networking is Achilles' heel. You absolutely need to know networking, right? And it's not a favorite topic for a lot of people. These are gold. Keep them. And what we did was we actually defined a program to upskill because all they needed to know was the terminology change in the cloud for networking. But I mean, that's your fundamental stuff, right? And that's critical. And so that actually became later on their superpower, right? Because so many companies did not want to deal with networking. They had no interest. It was too abstract. And so these talent were golden for that system integrator company. Vendor interoperability events and industry initiatives. So obviously folks talked about some of the incredible events and initiatives that are being led. One thing I would want to focus on is interoperability. That's been a passion of myself personally and folks that I've been working with. Some of you in the room have been to some of these interop workshops. You know, Mike and team, you've been to that one as well. So what we do is we gather in a room. I mean, you're welcome to scan these QR codes. It shows you what we've been up to. But we essentially gather for 3 days, and we pick a technical topic that is related to cloud, like scalability, something that's really hard to traditionally just test by yourself. And we say, okay, so we want to test scalability and interoperability using, let's say, NDI. We get together. It's a very technical event. It's not to prove anything. It's not to prove any one technology or the other. It's literally, how do we get to a point where we break the software because we're scaling it so much? How do you learn the limits? You know, so that next time our partners are with customers, excuse me, they have a much better clarity relative to their, not only their own software, but then how it interoperates with other software. And that clarity comes from observability, right? Kind of going back into what some of the things that the folks were talking about. And so some of the areas that you can take a look at, because again, I don't want to keep you too long, right? Some of the things that we're doing at AWS for media and entertainment, not just for broadcast, you're welcome to take a look at that, see some of the customer use cases, solution samples, and then encouraging you, if you want to upskill your teams, reach out or take a look at some of these resources. It's completely up to you. And then some of the demos that we do in trade shows, we actually publish what these demos are, right? And so the latest obviously is NAB 25, so you can see what we've done in live cloud production. If you were not at NAB, if you did not see the kind of the end-to-end, like the cars, the game simulation, and then the actual PCR near our booth, I would encourage you to do so. And so that's it for me. I will stick around for questions, but thank you so much for hanging.
Thank you very much, Noor. Someone just suggested to me that I should use AI to read the bio, and it's going to have Anthony's voice for the next meeting. So it would be great. So, still.
The continuation of my demos, but I don't think we have time for it.
Yeah. I still have some at the end.
Okay.
So we take pictures quick.
No, these are appendices.
It's gonna go quick. Put your video on. Okay. And I have a little say, and Anthony has to talk later on. But after that, right now we're gonna have a panel with Darby, Noor, Simon, and Mike is still online. So please come in and you can ask your questions. I'll grab some microphone. Check. And you have yours. Okay. So anybody has a question? Anthony. Busy with the microwave.
Someone alluded to it, I think it was maybe Mike, encryption and protecting the data as it goes in, as it goes out, in regards to, obviously protecting the IP.
Anything about that, Mike?
Well, yeah, encryption's important. Typically, there are different security standards. Like I think on one of Darby's slides, it talked about SOC 2 is one of the things where you go through different phases. But as you work with cloud systems and try and deploy them in large customers, you have to document how you keep things secure. One of the two key things are securing media in transit, so while it's being transferred, and protocols like SRT allow you to encrypt the information. And the other place where you need to encrypt typically is at rest or when you're storing the media. And fortunately, services like AWS S3 enable that. So it is very important to keep your media secure. Piracy is a real thing, but there are tools in the toolbox today to do that.
I can maybe add that, at least from an AWS lens, security is what we call a shared responsibility. So there's the concept of a shared responsibility model. This is public. You can take a look. It's a very nice visual, whereby AWS is responsible for the security of the cloud, right? So the underlying infrastructure, the data centers, all of that. But then the top layer, if you were to kind of imagine like a cake with layers, customers are responsible for the security in the cloud. And so, yes, the services enable things like encryption, whether they're databases or storage like Amazon S3. However, it is the decision of the user to decide to turn that on and off, right? To clarify it.
Yeah, and so that shared responsibility model therefore means the end user needs to understand and put those things in place, but the tools are there.
Anyone else? Over there, Tony.
Okay, a nitpicky question, but that's what we do here at SMPTE. For Simon, when you talked about the latency within the MXL, I presume is one function looks at the same content, and I was just wondering what the latency number I think you said was 2 milliseconds, very, very low. What causes any latency at all if they're all looking at the same memory all the time?
Well, if they're all looking at the same memory, you're asking where the latency is?
Yeah,
So
you talked about a very, very small latencies in an MXL.
Well, in the MXL, we haven't measured it yet because we don't really have access to it at the moment. But what we're hoping is that it reduces the latency because it allows for the media function to write into the memory as quickly as it can and allow the next media function to pick it up as soon as that function error that media is made available.
Okay, so okay, that explains it then. You're talking about the latency from one thing depositing a change onto the MXL to another thing picking it up. Okay,
Exactly.
great. That's good.
Just to further answer the question, in the MXL SDK requirement, what would define latency inside memory is the size of each grain. And at the starting point, video has been defined as 1 frame, as latency is not as sensitive as in audio, but straight from the get-go, the size of the grain are configurable for audio, so they can be very, very small or less latency, basically. But that's inside the platform. Anytime you exit, you have to deal with 2110 or NDI or Dente or any audio latency that streaming adds.
But one of the things about the networks, excuse me, is because of the network speed, you can transfer a frame much faster than 16.67 milliseconds. The challenge with networks is sometimes there's congestions, there's hiccups. And so if you're doing 2110, packet pacing becomes hard and important. If you just leverage the speed of the network, you can bring in the frames across the network quite fast. And then your latency becomes setting a buffer so that everything arrives, every channel that you need to potentially have at the switcher is there. And so you set a little bit of buffer, but it doesn't have to be very big.
All right, so I've got a question about troubleshooting, and especially, again, when you do remote productions. In a regular linear production, you depend on, especially in a broadcast center, you depend on your operators to be the first sort of point of contact for troubleshooting before the engineers even get called in. In this sort of world, is there a need to sort of add more skills to their repertoire to ensure that it can continue this way? Or is there a better way where somebody figures out almost immediately?
I can start to answer that, but
go ahead.
Yep. So yeah, just looking at like operationally, we build things within the user environment that kind of allow them to bubble up in conjunction with the user operator tools. So in a traditional sense, yeah, maybe it had to have multiple monitors. Now we can kind of place some of those alerting and alarms directly within those UI elements so that that can be their first point of not only am I operating, but yes, I also have eyes on what that operation is. And if there's some degradation in that I couldn't see apparently through audiovisual means, that I can start to see something like, again, some latency creep or some other, I'm oversubscribing on CPU or GPU allocations, I can start to then put an alarm bell out and say, okay, yeah, if the system hasn't already alerted somebody else about that, I can also be another case of saying like, hey, I think there's something here, and then that can be addressed that way.
I think I can maybe add that you can advance monitoring and observability with tooling, but operators may not need to learn these tools. To give you an example, maybe they care about seeing logs that are telling them something is off, but often when you collect a lot of logs, they're not really human readable. And so and that's actually something that we did recently with some of our partners to say, why don't you use generative AI whereby we collect logs through a service called CloudWatch, right? So we're collecting logs like any other tool, but then what we do is we actually push that to generative AI and LLM, which summarizes the logs and produces a very readable summary, let's say, that operators can then use, and then you can present it to them. Right. So maybe it's not about necessarily changing the skill set on the operator or the human side, but giving them better tooling.
And something else that we're also trying to tackle is really at the button push level. So sometimes you want that feedback that you push a button and something happened. And so we're experimenting with, well, if you push a button, there's a border around it. And when it receives the acknowledgement that the thing happened, either it fills up the button or there's things like that. So these are all things that it's still relatively new for our operators that they are learning themselves as to how they're going to operate in this environment.
Got a question.
I just
it's a future.
sorry.
Sorry, Mike. I just have a futuristic question. How about quantum computing instead of traditional server in the future? Is this all going to go away, the latency and everything else? Because now we're going to get like, I don't know, 100 gig back up and down.
Yes. The answer is yes.
I mean, for encryption, it does a wonderful job, right? Maybe when they become a bit smaller and cheaper, sure. Yeah.
I have a question online here. Sorry. This one's for Simon. Really, internally we have a couple funny sayings and we have a couple, funny things. We talk about the timing soup, and we talk about embracing production offsets. Could you maybe talk about some of the realistic, like get to air today type of production offset embracing that we as broadcasters have to do to make it work today?
Well, today, so we have what we call left to right productions where there's no return feeds or anything like that back into studios or anything like that, or back into the ear. So that is when you have a feed coming into production, something happens to it, there's a contribution, there's some graphics added to it, and then it gets spit out into a stream or on the air. And we had some demos at NAB where we had some vendors try to tell us that latency is not important in this environment. And while they were doing this demo, Pasquale, who was doing the talking, I noticed him that he scratched his head, and I was starting to count 1, 2, 3, and then I was looking at the multi-viewer, and by the time that I saw his head get scratched in the multi-viewer, it was 20 seconds from the camera to the full output. So 20 seconds is an insane amount of time in what we're used to. But even the workflow that I was showing, where that we had some cameras going in and then we had to return feedback out into the studio. We used to have that workflow at in the SDI world that was under a frame, and but now what we were able to measure with the multi-streaming in and out of the COTS, we're still over a second or two before we get that return. So then you count that back into the camera that captures that video again, that goes back out to program. So you're just cascading. So now it's like up to 4 seconds by the time we get there. So it gets really complicated, and it gets worse when you start talking about audio. Just plug for you, Anthony. Especially for comms. So if you have, if you're starting to talk about mixed minuses and side tone is not possible to do in software at the moment. So it has to be localized to the individual. So there's a lot of variables, and there's a lot of latency in the chain that we have to try to solve. So that's why we're so focused on trying to reduce that latency as much as possible.
Thank you very much. Oh, Roy, last question.
Sure, Nora, first I want to express my shock that you mentioned salespeople are motivated by how much they're getting paid. But my question and I hope this is a fair question, but I ask it with respect, but just regarding a specific, if there's an instance in the cloud generating a web UI, and say that web UI has video playing in it, it's viewed from the ground, would egress charges be applicable?
Yes.
Yeah.
Nice try, Roy.
Was worth a shot.
Well,
But
thank you very much.
ingress costs are not really there. So there's that. And so I do mention that because I do feel it is a little bit important. So bringing content into the cloud is free with an asterisk, depending like if you're using other services, whatever. But in general, bringing content is there. The reason I bring that up is especially in contribution, usually the bitrate and the bandwidth needed to do that is significantly higher than the streaming and the distribution side. But yes, egress has a cost.
Thank you very much. I'd like to have a big applause because we're running out of time. And I'd like to thank Simon, Darby, Noor, Mike online, Anthony sick at home, and Henry in the UK. And Tony has some present to do. So I'll give the mic to Tony because he's got some interesting item to give away.
So we got some giveaways. So we can do this. I've got 4 giveaways. We can do as one batch or we can do 4 separate. Now, one of them is a mouse pad. So, but together. Okay, Reed, where are you? Spin the wheels. So you got a little number on your name tag. So hopefully Lee will spin your number. Right on the right-hand side. Sorry, left-hand side. 21. 21, going once, twice.
See the little number there?
Next.
Okay. Remove. Next.
33. I should check. Go again. So while Reed's doing that, we haven't published June's meeting yet, so it's still fluid. But what we're looking at is the CBC transmission department is inviting a bunch of us, i.e. we don't know the number yet, up to the CN Tower to visit the transmission level, which is level 6. Has anybody been up to level 6 before?
Yeah.
Oh, there's a few. 63. Perfect. So, Peter, good. So we will send an email once things get materialized. This is going to be a members only event. So you've got till the end of May to get a membership and get $15 off if that's applicable for you guys. So then, yes, and then we might do a pub or a beer at the Steam Whistle. And they also have a tour, so maybe we can combine both tours. Yes, so with that, we are going for a beer to Hops, which is across the road, but you got to go to the traffic light or you can jaywalk. It's mid-block. Do return these, guys. If you don't, you're going to turn into a pumpkin if you leave the elevator. And I think that's it. And thanks everybody for coming. And thanks to the presentation crew.